Good day, everyone. I want to welcome you to my lecture today. Today is September 23, 2020. I'm actually going to walk you through another exciting topic that we call types of studies. I could remember in the last lecture, I actually walk you through different method of collecting data. But today, the focus is actually going to be what are the types of studies we have, you know, when we're talking about uh, research, okay? And I'm actually going to be walking you through that with some examples of them. So when we talk about types of studies, we got two types of study. One, we have observational studies and we have experimental studies. So I'm actually going to walk you through, you know, one after the other, and I'm actually going to, uh, cite some examples. But let me first start by introducing you. What do we mean by observational study? And what do we also mean by experimental study? Okay, so I'm going to start from observational study. Okay, so by observational study, of course, that simply means we want to observe what happens. We find ourselves in a world where we actually want to make inquiry about situation of things around us. Okay, and of course, if you can remember what we did last time when we talk about observation, okay, is a way of observing things. Okay, so uh, an example of that, if you look at the opinion, poll that we normally conduct, okay. The essence of conducting that is just to be able to get information, okay, from the respondents about situations around us. For instance, the uh, presidential election is around the corner in the United States, okay, and of course there have been series of opinion polls conducted by different kind of research organization, media organization, and so on like that. Just they actually want to predict the candidate that the majority of electorate will favor at the end of the day. Okay, so that is an example of an observational study. So now, let me just give us a clue about experimental study. In experimental study, uh, what researcher, instead of observing, so I think what researcher is actually going to do, the researcher is actually uh, going to embark on a serious experiment where it's actually going to identify two different kind of groups. There's going to be experimental group, and of course there's going to be a control group, of course. And he actually going to assign subjects, which I call the units, the smallest unit of measurement into the two different groups, okay? And that will enable him to compare, uh, you know, the treatment, people in the treatment group with the people in the control group, okay? So, and that type of study can be called experimental study. And in experimental study, of course, researchers impose a treatment or randomly assign subjects to a group. But in the case of observational study, researchers don't do that. Okay, the researcher just going to observe, probably based on the available data and stuff like that. It's not going to go through the rigorous way of assigning treatment subject to different kind of groups. Okay, now I'm actually going to walk you through an example right now, uh, where I want to talk about the tanning and skin cancer. Okay, that is the study. Now, let us investigate whether this is actually going to be an observational study or not. But I want to tell you what I want to showcase right now is actually going to be example under observational study, because what I expect at the end of this lecture, uh, you will be able to identify the difference between the two types of study. Now, let us have an example on observational study right now where we actually want to focus on tanning and skin cancer. Now, in an observation study where we want to use 1,500 people, okay? Now, selected a group of people who had skin cancer and another group of people who did not have skin cancer. Now we have two different kind of groups: those who have skin cancer and those who do not. Okay. Now the group membership based on innate characteristics in the subject. Okay, they were not assigned to a group. Of course, we're actually going to ask all the participants in the two different groups, okay, the same question, and the question is whether they used any bets. Okay, the question we want to ask from the, don't forget I said, of course, we have two different kind of groups, okay? Those who have skin cancer and those who do not have skin cancer. And we ask everybody in the two groups the same question. And the question is whether they used any bets. That is the question. So that is an example of an observational uh, study, okay? Now, another example of observational study is, when we try to look at, sugar and blood pressure, okay, where we try to enroll 100 individuals in the observational study, okay, and of course we give them diaries, and where we actually record everything they eat in each day. Excuse me. Now, from this the amount of sodium in the diet is found. Of course, we know there's, in every food we eat, okay, we can actually measure the amount of, sodium in the diet, okay. Now, not assigning subject to any certain amount of sodium, okay, they actually choose it on their own, okay. They actually choose that on their own. Actually, what we're trying to say is that in the case of experimental group, it is the researcher that we assign, the subject into two different kind of groups, okay? But in this case, of course, we are not assigning, okay, to any certain amount of sodium, okay? So they actually choose it on their own, okay? And when they do that, then we measure their blood pressure, okay? We measure their blood pressure because I think the study is just trying to measure the effect of sodium on blood pressure, okay? So we measure their pressure, their blood pressure at the end of the day. So that's an example of observational study. Now, uh, observational study can also be classified into one, retrospective and prospective. Now, what do we mean by retrospective? Of course, when you go retrospective, it's just like you are looking back at records, okay? And that is the reason why most of the students, if you want to carry out your research and you don't really perform experiment, maybe probably you want to use available data that have been collected by people. Then it means you are actually looking at the past record, okay? So that's an observational study, which we call retrospective, okay? When you are looking at the historical data, okay? Like the example that I gave, the tanning and skin cancer, because we already have, what is it called? That study have already been conducted, okay? Where they have in the tanning and skin cancer, that I mentioned the other time, okay? Uh, in this study, it was not the researchers, that really, some people have already done this, collected the data before, only that you use the data for your analysis, Okay, so that actually falls under retrospective because you are looking back at records of data that are available for you to use. Okay, so and this can also be a case control study. Okay, can be a case control study because you are actually trying to look back. So anytime you look back where you don't really perform the experiment yourself, I think that is what most of people, researchers around, that's what they do. Okay, then it can also be prospective. What do we mean by prospective is just that we're going to identify subject. When I say subject, what do I mean by subject? You know, subjects they refer to the, the unit of measurement. Okay, for instance, in hospital, the subject are going to be patients. In teaching, um, those who are receiving treatment, who are receiving lectures, are the students. In that regard, students are going to be subjects. In the case of, maybe the example I started from politics the other time, where we conduct opinion to be able to determine, uh, the percentage of those who will likely to vote for a particular candidate. Of course, the subject are going to be electorates, okay, the voters, okay, the eligible voters, okay. So in the perspective, of course, we're actually going to identify subjects then and collect data as events unfold, okay. We're going to collect data, okay. And of course, when you do that, in the case of sodium and blood pressure that I talk about right here, of course, we actually collect this data and we measure their blood pressure, okay. Now, and of course, in marketing, observational studies are often used in marketing, or studies, particularly in marketing where, a particular marketer will actually conduct an opinion poll, you know, to ask about, you know, the reason why consumers actually have a preference for their products, okay, or to be able to investigate whether consumers really like their product or not, okay. Of course, observational studies can also be used in that regard. The observational study can also be used in health studies, okay. For instance, we are in the middle of pandemic right now, where data are being generated on the cases of the COVID, the number of death from the COVID, the number of recovered from the COVID, and so on, like that. Okay. Now, I made mention of a case control study the other time under observational studies. Okay. And I said the conclusion of observational studies are not as strong as experiments because in experiment, I think I'm actually going to give you this example right now. Maybe you're going to see the difference between um, observational study and the experimental study. Let me give you this example. Let's say, for instance, you actually want to study relationship between, the smoking and incidence of lung cancer. I'm going to say that again. Relationship between smoking and the effect of, and the incidence of cancer. Okay. Now, what you are trying to do is just to look at the effects of smoking on the incidence of cancer. Now, if you want to do that, if you want to go by experimental study, or let me first start with observational study. If you want to go with the observational study, of course, you need to collect data on people who have smoked for so many years. Okay, let's say for instance, some people started smoking at the age of 20. Okay, and they've smoked for 10 years, which means right now they are 30 years of age. Okay, now uh The only thing you just need to do, since they've they've smoked for 10 years, then you're actually going to measure their lung cavity. Okay, you're going to measure their lung cavity. Okay, now if you measure their lung cavity, of course, uh, uh, you know, you can now use that. You can compare that with those who haven't smoked at all. Of course, those who haven't smoked for 10 years uh, are those ones that are going to actually going to be in your control group. Okay, now you are using the data you are using now. Of course, you are going historical. These people have smoked for 10 years, and maybe they started smoking at the age of 20, and right now, okay, they are at the age of 30, which means they have smoked for 10 years. Then you measure their cavity. Now that is an observational study. But in the case of experimental study, what you need to do, you need to look for those who have not smoked before, and you're actually going to ask them to smoke for 10 years. You're going to monitor them. You're going to ask them to smoke for 10 years. Okay? Now, after smoking for 10 years, then you actually going to measure their lung cavity. Okay? And of course, you're going to compare their lung cavity with the lung cavity of the control. Now, in that situation, we have an experimental study. Now, the advantage of the experimental study is just that you are able to control, because these people, they are your cohort, and you monitor them, you monitor them for 10 years. But in the observational study, you were not able to monitor them for 10 years, but it is just only on record that they've smoked for 10 years. Okay? And because what we use in experimental study, and that is the reason why experimental study is the whatever recommendation we make from experimental study is actually stronger than the observational study. And I'm actually going to tell you the reason why the conclusion based on experimental study is stronger than observational study. Is because in observational study, it's because in experimental study we randomize. Okay, and what do we mean by randomization? Of course, the randomization is the allocation of treatment to subjects, without favoritism or biasedness. Okay, without any favoritism or biasedness. Okay, and when we have reason why we randomize. Okay, we randomize for 3 reasons. Okay, randomize we protect against bias. Okay, randomize we permit conclusion about cause. And number 3, randomize actually justify using a probability model. Of course, I'm actually going to explain this one by one. Now, don't forget that I said conclusion based on experimental study is stronger than observational study, and the reason why it is stronger than observational study is because of the randomization that we do in experimental study. And the reason why we need to randomize is because of these 3 reasons. It protects against bias, it permits conclusion about cause, and justify using a probability model. Now, when I say it protects against bias, what do I mean by bias? Of course, bias is due to systematic variation that makes the groups you are comparing different, even if you have not even applied treatment. We don't want a situation whereby without applying treatment, we don't expect difference in the groups of subjects. In a situation where difference arise before applying treatment to this group of subjects, then that will induce bias. And let me tell you this. There's something I'm actually going to tell you right now. I don't know whether you guys have heard about William Cochrane. Of course, William Cochrane, uh, that lived between 1909 and, and 1980, okay, actually saw the reason why we need to randomize. William Cochrane taught for so many years at the Harvard University, okay, and he was actually one of the pioneers of experimental design, okay, and of course, experimental design was a subject that he taught for so many years at Harvard. Uh, there was a day he was telling the students, about his early experiences, okay, in which he decided, you know, wrongly, okay, he decided wrongly, uh, as it turned out that it wasn't necessary to randomize, okay. Uh, he was actually performing an experiment with rats, okay. He was trying to test the effects of special diets, okay, on the weight gaining ability of rats, okay. Now he actually worked with a co-worker, okay, and the work was a study of rat nutrition, okay, where they are actually comparing a new diet with a control, okay. Now, to decide on which rat received the special diet and which received the control, of course, the two of them simply grab rats, one at a time from the cages and put them into one group or the other, okay? And they thought it was largely a matter of chance which rat went, where. It later turned out, according to Professor Cochrane himself, that he had been acting as though he felt sorry for smaller rats, okay? At any rate, without knowing it at the time, he attended to put the smaller rat in the treatment group. Okay? He put the smaller rat in the treatment. The smaller rats, they don't have enough weight. Okay? And he actually put most of them in the treatment group. And the larger rats in the control group. Okay? And as a result, the special diet didn't look as special as theory had predicted, because before the research, the theory had predicted, the significant effect of the special diet. But the mistake made by Cochrane as at then was that he puts those bigger rats, in the control group, and the smaller rats in the in the experimental group, because the experimental group actually have the special diet. Okay? And as Cochrane told his class, if only he had used chance to decide which diet each rat ate, he would not have gotten such biased results. Okay? So, which means basically what we actually need to do is that uh, experimental study allow us to randomize. Randomizing means like in the case of experiment performed by Professor Cochrane, it's supposed to have, you realize they're supposed to have done that in a way that any of the group, whether the experimental group that have special diet, the control group, without a special diet, any of the group can receive any of the rats, okay, whether smaller or a bigger rat, okay. So the rats, any rat should have equal chance or equal probability of being assigned into any of the group. So Professor Cochrane realized the mistake. He acknowledged that, and he told the students at the Harvard University about his experience. Okay? So I've just justified right now the reason why we actually need to randomize. Okay? When you randomize, it's actually going to protect against, bias. Okay? Now, another thing that I'm actually going to, talk about is that, do you know that even the greatest scientists could be misled by hidden bias, because I want to tell you that we could have, you know, those who are experts in the field. I could remember in 1914, I believe you guys know the world famous Mayo Clinic. Okay, the world famous Mayo Clinic was founded by two brothers. I think you guys know that, who were outstanding in medical uh, pioneers. Okay, now I just want to tell you now that even the best of scientists can be misled by hidden bias. Okay, I could remember in 1914, Charles Mayo. Okay, Charles Mayo, one of the uh, world famous, the founders of world famous Mayo Clinic, published an article in the Annals of Surgery. Okay, where he recommended surgical removal of thymus gland. Okay, as a treatment for respiratory obstruction in children. I'm going to say that again. An article published in the Annals of Surgery in 1914 by Charles Mayo, where he actually recommended, surgical removal of thymus gland as a treatment for respiratory obstruction in children. And the basis for his recommendation was a comparison of two groups of optosis. Okay, he had two group of optosis. The two groups, group of children that have died. What he did, children who have died, from a respiratory obstruction. Okay, and adults who have died from other causes. Okay, you know that is what I mean by conducting autopsy. Okay, on these two groups, children who have died from a respiratory obstruction and adults who have died from other causes. So Mayo's comparison led him to discover that children who had died of obstruction had much larger thymus gland than those in his control group. Okay, I'm going to say that again. Mayo's comparison actually, led him to discover that children who had died for a respiratory obstruction had much larger thymus gland than those in his control group. Okay, and this difference led him to conclude that the respiratory problem must be due to an enlarged thymus. Okay, in his article, he recommended removal of thymus, even though the mortality rate, for that operation was very high, because we got situation whereby bias could come with fatal consequences. Okay, because the recommendation of Mayo was so dangerous. Okay, sadly, it turned out that Mayo had been misled by hidden bias. Okay, he had been misled by hidden bias. Unlike most body parts, okay, which get larger as we grow from childhood to adulthood, the thymus gland actually becomes smaller as we age. Okay, although Mayo didn't know it, the children gland that he considered too large were, okay, in fact, normally size. They only seem too large in comparison to the smaller gland of the adults in the control group. You see that now? So Mayo was obviously misled. Okay, so despite his use of a control group, okay, because a hidden source of systematic variation made his two group different without randomized assignment. Okay, so what I just want to tell you right now, without you randomizing an assignment, statistical inference about cause and effect is risky. Okay, and that is the reason why the best way to protect against bias from hidden sources is to use chance to create your group. So using chance to create your group is just, trying to, you know, uh, assign. It means, any subject can go to any group. Okay, every subject have equal chance of being assigned to any kind of group. Okay, so if you're using instruction of chance, if you're using randomization, of course, that will actually protect against bias. Okay, so, and of course, this is what we do in experimental study that actually make experimental study, to be more stronger than the observational study in terms of recommendation that is coming from the experimental study. Okay, so another thing that I also want to talk about as a reason for randomization is I talk about the fact that it justify, randomizing actually justify using a probability model. Of course, in the subsequent lecture, I'm actually going to be walking you through something that has to do with regression analysis and the analysis of variance. The regression analysis and analysis of variance and some models in statistics actually rely on a probability model, which actually requires independent normal errors with constant variance. Okay, so I want to tell you that basically statistical models are probabilistic in nature. And if we don't randomize, there's no way we can actually justify using a probability model, because random, uh, uh, what actually, uh, make a probability, probability only thrives in randomization. Okay, probability thrives in randomization. And that is the reason why, if you look at assumptions underlying the use of models, okay, whether regression analysis, analysis of variance, and whatever model we use in statistics actually have, kind of assumption. And these assumptions, actually centers on the probability requirements, the probability requirements of the errors. Of course, we know in any model, in statistical model, we always have unexplained variation, which translate into errors. As we know, there's no perfect model anywhere in the world. Okay, and that is the reason why, that's actually occur. Now you've seen uh, you've seen the reason why experimental study is actually far better than observational study, because of the fact that we randomize in experimental study. Okay, and that was, if you read the example that I'm actually citing right here, yeah, that was what I'm going to say. Can you randomly assign individual to be in a cigarette smoking group? Okay, so can you randomly assign someone to use a temibad if there's a risk of cancer? That's going to be no. Like in the case of observational study, we don't randomize. And the reason why we don't randomize in observational study is because at times it could be costly and it could be dangerous. And that was why I asked a question: can you randomize? Can you randomly assign individual to be in a cigarette smoking group? And that and the question is no. Okay, because those who you want to use for the study, you need to seek for their indulgence, whether they're going to smoke or not, before you can do that. So in the experimental study, so in observational study, and that is why we we can't do that. We can't do randomization. Okay, so and at the same time, we cannot randomly assign someone to use a tanning bed if there's a risk of cancer. We can assign. We can't do that randomly. Okay, and that is the reason why uh, observation study also has its own advantage. Okay, in this kind of situation, observation study is preferable to experimental study. Okay, now another thing I'm also going to talk about is what I'm called the match case control study. What do I mean by match case control study? Okay, if somebody have a disease, okay, I'm actually going to look for somebody that do not have the disease. Then I'm going to match them. Okay, so in matching them, of course, just like recording, I'm going to subject them into the same kind of activity. Okay, so, and if I match them, okay, it's like match case control, because I'm using those who do not have the disease as case control, as a control, and then the other one, the other group that have the disease, okay, I'm actually going to match them, and then the essence of that is that it's going to help give credibility to relationship in such situation. Okay, so I'm actually going to want you to see a picture right now. Okay, we are that talk about that illustrates match case control study, and I'm still want to use the tiny bed and the skin cancer. Okay, like I said, case control, case those who have the cancer, who have the disease, control those who do not have. Okay, I'm actually going to, it's like I'm having two sets of individuals. Okay, and I'm actually going to match individuals on the characteristics of interest. Okay, and you know what, if, let me give you this example. If a 15-year-old guy has cancer, I'm also going to look for another 15-year-old guy that do not have cancer. Excuse me. If 35 years old guy has cancer, I'm going to look for a 35 years old guy without cancer. That's exactly what I'm saying. And not only that, not only in terms of age, in terms of outdoor activity, in terms of the diet, it has to be, they need to have similar and so on like that. Okay, so that's exactly what I'm trying to showcase right here. Now, the two individuals are here. The one by the left, the guy with the cancer, and the other one without cancer. Okay, the two individual, similar in many ways. You know, so that is actually what I'm going to do. So, and that's exactly what we call the match case control study. Okay, so we try to match cases and control who have similar characteristics to overcome the study limitation due to confounding. Now, what do we mean by confounding? I'm actually going to tell you the essence of, let me give you this example. In a situation where you actually maybe you're looking, you have a farmland, okay, and you are testing for different fertilizers. Maybe you got fertilizer A, B, C, D. You got 4 different kind of fertilizers. You actually want to test whether the 4 different fertilizers are significantly different from each other or one another, or they are the same in terms of the way they support the yield. Okay, without putting into consideration the soil type. If you have different soil type, there is possibility that the different in the fertilizer, okay, the different in the you're okay, in the fertilizer may be attributed to the different soil type. Therefore, in that situation, it means soil type is being confounded. Okay, in that kind of situation, you may not be able to tell. Okay, you may not be able to tell whether the reason why a particular fertilizer, maybe a fertilizer A, is greater than fertilizer B in terms of ability in supporting growth of plants. Okay, so which means you need to put into consideration soil type. Okay, so but you know what, if you really want to avoid that kind of situation, if you try to match cases and control with similar characteristics, you're actually going to overcome that limitation. Of course, in the next lecture, I'm actually going to stress more about confounding. Okay, so now I think I also would like to talk about the cancer stuff that I've been talking about. Okay, cancer and no cancer in the match case control study. Okay, Now, if you take a look at this, if everything else seems to be the same between these two people, I'm talking about these two people, okay, that I just showcased right now, okay, except, okay, tiny bed use, and the tenor has cancer, then that gives some credibility to cancer and tiny bed being related, okay? So they have every other things in common, okay? But the only thing they don't have in common is the tiny bed use. Then one could be thinking that the tiny bed use could have, could have something that has to do with cancer, because you've compared them, you know, on different kind of characteristics, and in these different kind of characteristics, they are similar, except the tiny bed use. And of course, that will actually give you an opportunity to be able to, relate, okay, the tiny bed use to cancer. But in a situation where you don't do that, okay, in a situation where you don't really do that, okay, then uh, of course you may not be able to tell whether the differences between these two individuals, okay, may not be. I mean, maybe maybe the differences between the two individuals, one of the certain factors, that are hidden, may be the one that may actually cause the disease that we're talking about. It may not even be tiny bed. But in this situation right now, of course, every other characteristics that was compared look the same, except the use of tiny bed. Then with that, then we can actually be talking about, looking at the effect of tiny bed on cancer, believing that tiny bed use could have led to incidence of cancer. And that was why I said it gives a rebel to the devil's advocate, saying the cancer could have been due to age. Okay, it could have been diet. Okay, because some people may argue that out. Okay, in an attempt to look at the effects of a tiny bed use on cancer. Have you really compared their diet? Do they have the same diet? Have you compared their age? But now you're going to say, okay, you know what? For the treatment group and the those who have cancer, those who have who do not have cancer, of course, I've considered their age. They got the same age. Oh, they got the same diet. In fact, they more or less have the same activity, except the tiny bed use. Therefore, that will give you an assurance to relate the tiny bed use to incidence of cancer. And that was why I said the cancer is not due to age, because they are the same. If you look at this guy, the age of the guy with cancer and with the guy without cancer, they got the same age. And they also get the same diet. Because if they don't have the same age and they don't have the same diet, and you don't consider effect of age and diet, and if you are only focusing on the tiny bed use alone, then it means age and diet are being confounded. I'm going to say that again. It means those are hidden factors that may have potential effects on the response. And that is the reason why, match case control study is very, very important to remove confounding. Okay? And that's why we're doing that. So using a match case control study is not as strong as being able to use randomization. Though there's we get randomization, we get confounding. And don't forget, match case control study is still under observational study. Okay, and that was why I said using a match case control study is not as strong as being able to use randomization as in an experiment. But if it is not ethical to assign treatment group, it can increase the strength of the conclusion of the study. I told you the other time, it may not be ethical to use experimental study, because I'm going to show you the example that I talk about. That was why I asked a question right here, where I said, can you randomly, because in experimental design, in experimental study, we randomize, okay? Now, and that was why I asked you this question here. Can you randomly assign individual to be in a cigarette smoking group? You can't randomly do that, because you need to seek the consent of those that you actually, of the subjects, okay? That may not be ethical, okay? And can you randomly assign someone to use a tanning bed if there is a risk of cancer? No, you can't do that. And that is the reason why you need to use observational study in that situation, okay? So which means in this situation, you cannot randomize, okay? In this situation, you cannot randomize, but the only thing you can do in this situation, you can, of course, you can do the use of a match case control study that enable you to compare, okay, people, that have, group that have cancer, that have the disease, and group that do not have the disease. Of course, you are actually comparing them, across certain characteristics. Oh, they are the same in terms of age. Oh, they are the same in terms of diet. Oh, they are the same in terms of activity. But the only difference between them is the use of tiny bad. And of course, that may be actually because they get different, the difference between them is in the use of tiny bed. Of course, then we have a way to relate that to the incident of the disease. And that is the reason why I actually talk about that the other time. Okay. Yeah, that was what I said. That will give you some credibility to cancer and tiny bed being related, because you have considered, any possible hidden factor that may have effects. And all those ones have similar, is similar to the two groups. Okay. The next thing I'm going to talk about now, I actually want to talk about confounding. Okay. I actually want to talk about confounding. And what do we mean by confounding? I'm showing a graph right here. It's a map of Iowa. Iowa is a state in the United States of America. And of course, they are used to, kind of farming activity, okay? And you know what? Let's say you actually want to test effects of 3 fertilizers on the yield of corn, because they are known for growing corn, okay? And you actually want to test for the effect of 3 fertilizers, okay? But you know what you did? If you apply fertilizer A on all plots on the west side of the state, and you apply fertilizer B on all plots in the middle of the state, and you apply fertilizer C on all plots in the east side of the state, of course, when you are doing this, you are not randomizing, okay? You are not randomizing. And of course, that will induce bias, okay? That will actually induce bias. And that is the reason why I said the problem here is, if we see differences in the yield of corn between fertilizer group, okay, is it due to the fertilizer or is it due to the soil? Because we expect that in the west side of Iowa, of course, the soil that you're going to have in the west side of Iowa will be different from the soil you're actually going to have in the middle of the state. And it's actually going to be different from the soil that you have in the east side of the state. Of course, a different side of the state have different soil types. And that is the reason why, even if this difference exists in these 3 fertilizers, you can't really say whether the difference is just due to fertilizers or is due to the soil, okay? And this is because fertilizer and soil are confounded in the scenario. That's a bad thing here. Of course, I call it a bad thing here because you are confounding fertilizer and soil. And that is the reason why, in order to break out of that, then you need to randomize in such a way. And how are you going to randomize that? any side of the state, whether west, middle, east. Of course, what I'm actually going to advise that you should do, fertilizer A, B, C should be applied in west side of the state. Fertilizer A, B, C should be applied in the middle of the state. Fertilizer A, B, C should be applied in the east side of the state. Okay? Or if you want to do that in a way, you can actually randomize fertilizer in such a way that any fertilizer can go to any side of the state. Okay, if you do that, that is just going to be the way out of the scenario. Okay, now another typical example here is talking about the effect of sodium and blood pressure. Okay, and I put all subjects on the low sodium diet had their blood pressure measured by a registered nurse using a standard manual cuff and stethoscope. All subjects on the high sodium diet had their blood pressure measured using an automated curve and digital readouts. If you take a look at this, you got two different kinds of subjects. Okay, subjects with low sodium diet, subject with the high sodium diet. But you know what? You use a different measuring instrument for them. You know, that's a problem. Why do you have to use a different measuring instrument on them? Because the problem here is if we see differences in blood pressure, don't forget you are looking at the effect of sodium diet type on the blood pressure. If the difference actually exists in the blood pressure, okay, between the groups, between the two groups, now the question, is it due to diet or is due to the method of measurement? Because the diet and the method of measurement are being confounded. And it is not good to do that. You don't need to confound that. Okay? So, and that is the reason why if you are carrying out a study, like this is a mistake. Because a situation whereby, method of measurement is being confounded with the diet, that's a problem. If you have used the same method of measurement, then we will not be talking about confounding. Okay? If you have used the same measure, and that is the reason why, we are more or less like, oh, the kind of measurement that I use for this is the same kind of measurement that I use for the other group. Of course, in that situation, you don't talk about confounding. Any differences that exist, of course, it may be due to, it may be as a result of different groups. Okay? It may be, it could be attributed to the diet. But in this situation right now, you cannot really tell if differences exist. You can't really tell whether it is due to the diet or it is due to the method of measurement. Okay, so let me now conclude by saying the problem with observational study is confounding. Every observational study, you're actually going to have one of two factors that will be confounded. Okay, and that is a problem with the observational study. Okay, so sometimes we try to overcome the observational study by using a matched pair of case control. Okay, so when you use the matched pair of case control that I just talked about the other time, situation whereby you compare in the subjects a different group, you compare their similarity, you compare them based on age, based on certain characteristics of interest, and any difference between them. That difference, of course, that factors of the difference could be related to the response of the study. Okay, though this can still be part of arguments. Okay, so experimental studies, of course, uses randomization as a tool to fight the occurrence of confounding. So if you really want to fight the occurrence of confounding is not good. If you really want to fight the occurrence of confounding, then you need to randomize. But for your information, there are situations where randomizing may not be ethical, may be dangerous. Okay? There are situations where they could be dangerous. Okay? Now, I want to take you into experiment right now, experimental study right now. Of course, in experimental study, what we do, we actually going to have, you know, experimental group and control group where the researcher we actually randomize the subject to these two different kind of groups. Okay. Now, in the experimental group, we're actually going to have what we call explanatory factor, called explanatory variable, and we're going to have a response variable. Okay. We're going to have an explanatory variable. We're going to have a response variable. What is an explanatory variable? An explanatory variable is basically, you know, a variable that we manipulate. Okay, we manipulate to be able to observe its effects on another variable, and that's what we call explanatory variable. Okay, like a factor. An example of that, you know, uh, it could be dosage. Okay, it could be dosage, and you know what? Explanatory variable could be categorical in nature. And of course, if you look at the dosage that we have here, we have three levels of that. Okay, OML, 10 ml, and 20 ml. Okay, this guy here, the OML is more or less the control, while the 10 ml and 20 ml are the experimental group. Okay, it's more or less like you have two different kind of you know experimental treatment, and of course you have a control, and when you combine the three, of course you have three treatments. Okay, so the dosage is an explanatory variable. It's a factor that is categorical in nature right here. Okay, so the response variable could be the percentage of skin irritation. Okay, you know, for people that are doing what we call a cream formulation, okay, or those that are actually formulating something that you will take into our body, okay, of course, uh, they may actually want to measure the dosage, okay, the effect of different kind of dosages on the response variable, okay, on the percentage of skin irritation alleviated. Okay, maybe somebody have skin problem. Okay, maybe maybe something happened and the skin is being irritated. Okay, and you actually want to alleviate that. Okay, and you really want to alleviate that, you want to reduce this irritation. Okay, and you actually want to know what is the effect of different kind of dosages, okay, in percentage of skin irritation that will be alleviated. Okay, so this is a study, you know of that nature. Okay, so what you are going to do right now in experimental study, you're actually going to look for subjects. Okay, the subject are those who have skin irritation. Okay, those who have skin irritation. Okay, and you know what, in the experimental study, we're actually going to assign them into this dosage level in such a way that any of them you know have the same probability of being assigned into any of the group. And that was why I said randomly assign subject to treatment group. Okay, we randomly assign. If you're given is 0 ml, that's a placebo. It's like it's more or less like you are given nothing. Okay, so that's a placebo, because you actually want to know the effects of using something and not using something. Okay, using something is like, okay, the 10 ml and the 20 ml. Not using anything at all, it's a 0 ml. Okay, so of course, in experimental study, we're actually going to assign subject, and subject in this case are patients that have skin irritation. And of course, the essence of using this treatment or the dosage on them is just for us to be able to know whether these levels of dosage have the same effect on the alleviation of the skin irritation. Of course, we want to know whether different dosage we have different percentage of skin irritation alleviated. Okay, So the experimenter must actively and deliberately manipulate the factors. And because that was why I told you the other time, of course, the explanatory variable are factors, that we manipulate and, and observe the effects on another variable. Okay, I can decide to have a 0 ml, 10 ml, 20 ml, in fact 30 ml. I just want to look at the effect. Okay, so we got a way to do that. And of course, the experimental unit are assigned to at random to treatments. There is no favoritism. There is no biasedness in the allocation of treatment to groups. Okay, so that's exactly what we say. Now I'm actually going to demonstrate that right now. For example, I got a 6 mice here, and I want to randomly select them to 2 groups. The first group is actually the present drug group, and the second group is a new drug group. Of course, the present drug group is conventional drug, and the new drug group is actually going to be experimental group. Okay, so the present drug group is going to be control, because you actually want to compare, the effect of the new drug, on the mice. And that is the reason why, of course, the purpose of this study. Okay, so if you take a look at the 6 mice right here, I'm actually going to do the randomization. I'm going to use the randomization principle in assigning these mice to any of the 2 groups in such a way that, you know, uh, any kind of mice can go to any groups. Okay, any mice can actually be assigned to any group, so the probability is the same. Okay, and take a look at what I have right now. After doing that, of course, I can decide on the number that will go into each group to be fair to the system. Okay, I'm actually assigned 3 at random. Okay, when I say random, because if I don't do that at random, of course, I may not be able to eliminate, I may not be able to fight confounding. Okay, I may not be able to fight confounding. And when I'm doing this right now, of course, I'm actually going to, have a way to fight confounding. Okay, now you can see the mice on the 2 groups. Can you see that now? Okay, so what do I want to do? Of course, the mice are my subjects, and I've done a random allocation into 2 groups, group 1, group 2. In group 1, of course, I have 3 subjects, and in group 2, I have 3 subjects as well. And in that case, since I get 2 different groups, then I have 2 different treatments. Okay, the first treatment is actually going to be present drug group, and the second one is going to be the new, the new drug, which is treatment 2. Now, actually, I want to compare treatment 1 and 2. Okay, that is the purpose of the research. Okay, I want to compare treatment 1 and 2. Okay, and that is the way that is going to go. Now, in the case of the sodium and the blood pressure that we talked about the other time, if we actually want to do that, using an experimental way of doing it, okay, so if I have 20 subjects, okay, of course, the factor is going to be the amount of dietary sodium, okay, and the treatments right here is going to be, there are going to be 2 levels of treatments. Okay, we're going to have a low sodium diet and a high sodium diet. Okay, and of course, you know what I'm going to do? I'm actually going to split the 20 subjects into 2, 10, 10, in such a way that any of the 10 can go to any of the group. What are the groups that I actually want to compare right here? The low sodium diet group and the high sodium diet group. And what is going to be the response? Of course, the response is actually going to be the systolic blood pressure, because I actually want to measure the effects of the sodium diet type on the systolic blood pressure. That's exactly what I want to do. Okay, so what I just showcased right now is an example of experimental study. Okay, I want to believe that at the end of this lecture, you will be able to know the difference between observational study and the experimental studies. Okay, now, of course, like I said, uh, uh, looking at the sodium and the blood pressure, of course, the sodium is a factor and it's an explanatory variable, only that it has two levels. Okay, it has two levels, and level 1 is high sodium diet, level 2 is low sodium diet. Okay, and the uh, the response is a blood pressure. Okay, the systolic blood pressure. Okay, and the facts remain that we're talking about the amount of dietary sodium. Okay, so I think I've explained the reason the other time uh, why does randomization help. Of course, I told you randomization helps us to uh, you know reduce bias, and not only that, it fights against confounding. Okay, and it actually justify the essence of using probability model. Okay, don't forget any of the statistical model. All statistical model are probabilistic in nature. Okay, now if I want to go back to the state of Iowa, the other time where I was where we're comparing three type of fertilizer A, B, C on the growth of corn. We applied, fertilizer A on a particular side of the state, fertilizer B on a different side of the state in the middle, and the fertilizer C in the other side of the state. Okay, now if we want to, like I said, to fight against confounding, for us to have a reasonable result, we need to have randomized. Okay, so and that was why I said the effect of other factor beside the variable of interest on the response gets averaged out across the treatment groups. Okay, they're going to get averaged out, by the time you randomize. Okay, so they're going to average out across the treatment. I'm talking about other potential factors beside the one we're considering, beside fertilizers. Another potential factor that I talked about the other time was a soil type. If you have done randomization, that would have averaged out. Okay, and that was why I said all fertilizer gets some good soil and some bad soil. Okay, but in the case when you don't randomize, okay, when you don't randomize, of course there will be possibility that that is going to happen. Okay, so fertilizer here is no longer going to be confounded with soil because you have randomized. Okay, now when you randomize, let me tell you, fertilizer A, B, fertilizer A, we get bad soil. Fertilizer A, we get good soil. Fertilizer B, we get bad soil. Fertilizer B, we also get good soil. Fertilizer C, we get bad soil. Fertilizer C, we also get good soil. Definitely that would have averaged out with randomization. Therefore, in that situation where you have randomized, then fertilizer is no longer going to be confounded with soil. Okay, so like I said, randomization tends to spread the effect of control outside variable evenly across the treatment group. Okay, that means in the case of the state of Iowa that I talk about right now, okay, the effect of the soil type would have been spread across the treatment group, across the fertilizer with randomization. That's exactly what I'm talking about. Okay, now another example right here, make sure sick and healthy people are in both treatment group of a drug experiment. Okay, so you don't repeat the same mistake made by Professor Cochrane. Okay, the Cochrane actually acknowledged the fact that he made a mistake earlier in his career, when he failed to randomize, where he actually assigned bigger rats into the special diet and the bigger rat into the control diet, and the smaller rats into the special diet. Now, what we're trying to say in essence is that if some patients have disease and some patients do not have the disease, then what we're trying to say is that you do it in a way that both that are sick and both that are not sick, okay, they find themselves in both the treatment group and and the control group. Okay, so when you're talking about treatment group, means you're actually they need to find themselves in the both treatment groups. And make sure young and old people are in both treatment group of a drug experiment too. Okay, so when you do that, of course, I think randomization is actually going to guarantee that. Okay, so we can't completely know which things will affect the response. So we randomize to try to cover all the possibility. Because let me tell you something. It may be difficult to know all potential factors. Okay, now what we normally do, the factor that we can actually think about, if we randomize, then the other potential hidden factors that we don't talk about will have been, their effect will have been eliminated. Okay, and that was why we said we can't completely know which things will affect the response, so we randomize to try to cover all the possibilities. Okay, now, and that was why I said randomization reduces the chance that an uncontrolled outside variable will bias the result. I told you. So when randomization actually reduce bias. Okay, so if units are not assigned at random to treatments, then researcher cannot use the powerful method of statistics to draw conclusion. Of course, if you don't randomize, because randomization justify probability model, and all statistical models are probabilistic in nature. Then it means if you don't randomize, you cannot, use the powerful statistical tools to draw inference, to draw conclusion. Okay. Now, inclusion of a control group. Of course, in any research where you are trying to look at the effects of a particular factor on the response, it is advisable, you don't just compare, at times you could have different kind of treatment group, but it's advisable, in addition to the treatment group, you also need to compare control with them. Now, if you look at the dosage that I talked about the other time, 0 ml is the control. Okay, so the people in the people in that group will be given placebo. And you know what? When you are giving placebo, placebo does not have any effect. But we're not going to let the patient to know about it. Okay, they're going to think that they've been given drug. Okay, so we got a reason to include control. Okay, so we actually include control because that will enable you to determine the effects of the treatment. You actually want to see whether there's a difference between using nothing and using something. Is there any difference between using nothing or using something? Okay, because some people can argue it out that even if I fall sick and I don't even take any drug, I'm actually going to be fine. Some people can argue that out. So, and that is the reason why if you really want to know the effects, measure the effect of something, then compare that something with nothing. Okay, and that is the reason why we actually need to include control control group. In this case now, where I'm looking at the effect of dosage. Okay, of course, I'm actually going to, the one that the 0 ml is more or less like a placebo. Okay, so like I said, the OML group is a control group. Okay, and it is a treatment where nothing happens. Nothing happens. Okay, now we want to give the control group a placebo, just like what I said, to mimic whatever is happening in the non-control group, so everyone is treated similarly. Like I said, those people in that group, we are not going to tell them. They're going to think they are being given a drug. We do this all the time. Okay. Now, of course, I gave an example short. give a salt water injection. Okay, so I gave a lot of examples right here. Okay, now I'm actually going to go to placebo effect. Okay, like I said, placebo, when you're giving placebo, is more or less you're not giving anything at all. Okay, and of course, like I said, we actually need to compare something with nothing. Okay, now the placebo effect occurs when people believe they are receiving a useful and beneficial treatment. Of course, the patient that you assign to placebo, the belief they have is that they are being given drug. You are not going to make them to believe that they are giving placebo. Okay, and because of that, we have what we call single blind study and a double blind study. And I'm actually going to tell you the meaning of single blind study. In the single blind study, is like the subject are being blindfolded. Okay, the patient here that are giving placebo, they don't know which group, whether whether they are going to be giving placebo or not. Okay, they don't really know the kind of group they are into. I mean the subject. Though in the single blind study, the researcher actually know where a particular patient belong, but the patient themselves, they don't really know whether they are in a control group or they are in the treatment group. They don't know, and that's what we call single blind study. Single blind means one side is being blindfolded, and the subjects are at the receiving end in this situation. Okay. Now the double blind study is neither subject nor the experimenter know the group assignment. But what we normally use most of the time, is a single blind study. But I just want to tell you there are two different kind of blind study. We have the single blind and the double blind study. Now, the next thing I'm going to talk about now is some terminologies. I've been using subject. What do we mean by subject? Of course, the subject are the people, the animals. Something that we choose for a sample. The unit, the unit of measurement, the cases. Okay, it could be patient, it could be students, it could be electorate, and so on like that. And of course, I've explained to you what we mean by explanatory variable. Okay, explanatory variable is the same thing as predictor. It's a variable that explains. It's a variable that causes an effect. It's a variable that will manipulate and observe its effects on another variable. Okay, and the response variable, of course, is a variable that depends for its value on another variable. Okay, that's what I mean by response variable. Okay, so of course, then what do we mean by variable? Of course, a variable is anything that is liable to change. And that was why I said item that can take on many values: age, weight, treatment group, blood pressure, and so on like that. Those are variable. Okay, and that's when you are conducting research, you need to be able to identify your variable. What variable do you want to work on? That's actually going to be your variable of interest. If my variable of interest may be different from your variable of interest. Okay, and lastly, I'm actually going to talk about meta-analysis. Okay, and in meta-analysis, this investigates many past studies. Okay, there have been past studies. You now investigate past studies. Okay, studies that have been done in the past. Maybe you review. Maybe you're actually having a reflection on the study that have been conducted in the past to form conclusion about variable of interest. When you do that, you are doing what we call meta-analysis. Okay, and pulls information across studies. Okay, maybe a lot of people, different researchers have conducted a study in the past about what you want to work on. Then if you can review literature, okay, and have a reflection on what they have worked on, you're investigating, the past studies. When you are doing that, you're actually doing meta-analysis.